Hi everyone, so this video is going to talk about a few properties of radicals. So previously in the first section of this unit, we talked about multiplying radicals together, but we were very particular about the type of radicals we were multiplying together. So in the previous video, we would have seen multiplying radicals by themselves. So if we had the square root of 2 times the square root of 2, we would have discovered that that is in fact just 2. So now in this video, we're starting to look at multiplying radicals together that are different. So A times B. So two different radicals multiplying together. And we see here that if we multiply two separate radicals together, it is the same as a single radical with those two original numbers underneath multiplied together. So what that would look like is if we had the square root of 2 times the square root of 3, that is the same as the square root of 2 times 3, which is the square root of 6. So that's what we're getting at in this particular video. Previous video, we saw multiplying radicals by themselves. Now we're looking at multiplying different radicals together. And then by consequence, by extension, I suppose, then the other property has to deal with division. So if we are dividing two separate radicals by each other, that is the same thing as a single large root sign with the two numbers dividing by themselves. So for example, if you had the square root of 18 divided by the square root of 3, that's the same as the square root of 18 divided by 3, which is the square root of 6. So two properties that you can use interchangeably, right? You can use them to actually multiply together, or you could potentially go in reverse and split something apart. Similarly, you can look at using them to consolidate into a single fraction underneath a root sign, or potentially you could use it to break things apart if that's going to be helpful in whatever it is that you're looking at. So let's go through a few examples here of these properties. So in the first one, we see 3 root 2 times 4 root 11. So in the previous video, we also would have spoken about how when you multiply radicals together, you multiply coefficient by coefficient, so number by number, and then root by root. So if we look at this one, we've got 3 times 4, which gives us 12. And then we have the square root, and I'm going to write this out in a bit of a longer process here. You probably wouldn't use this middle line of work, but if it's helpful, use it. So we've got the 3 times 4, and then we've got root 2 times root 11. So that's the same as root 2 times 11. So then we can simplify that to be 12 root 22. And then in the next example, we have two roots that are dividing one another. So if we have the square root of 75 divided by the square root of 3, we can say that is the same thing as the square root of 75 divided by 3. Put it as a single division, a single fraction underneath that radical sign. So then we can simplify that even more. The 75 divided by 3 gives us the square root of 25, and then you need to get really good at recognizing that that is a perfect square. I can actually solve that and write it as a whole number, in this case 5. So then in the last example that we have here, we see a single fraction underneath that radical sign. And again, I just said you have to get really good at recognizing when you see perfect squares. And hopefully you recognize that there is both a perfect square as the numerator and a perfect square as the denominator. So both of those numbers are perfect squares. So in this case, we're going to use the division property, but we're going to go in the opposite direction, because that's not as helpful perhaps in some cases as looking at this as the square root of 9 over the square root of 49, and then seeing two perfect squares that I can then solve to give me a final answer of 3 over 7 by solving the square root of 9, solving the square root of 49. So these properties, depending on the circumstance, can be used in sort of both directions. You know that they are equivalent ways of writing things, so sometimes it might be helpful to use them one way, sometimes it might be helpful to use them another way, as we saw with part B and C here. So the final example that I want to go through is this one, which is a bit of a, it's a bit of a trickier question, I suppose. So we're going to write the square root of 32 in the form of k root 2, meaning this is what we want our final answer to look like. We want a number sitting in front in place of k, and then we want a root 2. So for this particular example, we're going to use this multiplication property, but we're going to go backwards. So we have this root 32. We're going to break it up into some component bits that will have a root 2 with them. So we can take square root of 32, and now I need to think about, okay, I know that I want to get a root 2 out of this. So I'm going to multiply this by 2. Or maybe I'll do it a slightly different way. I'm going to break this into 2 roots. The second one is going to be 2. So I'm going to rewrite square root of 32 as something, the square root of something, times the square root of 2. So I'm basically breaking up 32 and going, okay, 32 is equal to something times 2. What is this something? Or I guess you could look at it, 32 divided by 2 gives you that something. Either way you look at it, you're going to put in the square root of 16 here. Now again, third time in this video, I'm saying you have to get good at recognizing perfect squares. The square root of 16 is a perfect square, so I am going to solve that because I can. That will become 4, and then I have this extra root 2 hanging around. So the square root of 32 can be rewritten as 4 root 2. This is in the style of how it asked us to complete the question. It wanted whole number sitting out in front, taking the place of k, and then a root 2 tacking on to the end of it. So this is using this idea that I can take two things or a value and break it apart into its component bits. So I had 32 here, and I ended up with 16 times 2. So that's where I inserted and then took the square root of the 16 to get 4, and then the root 2 is left behind. Okay, so that is a few properties of radicals, 2 really. A multiplication property and then a division property, which hopefully through the examples you've seen can be used in sort of either direction depending on what the question calls for. And that's it.